Welcome, and thanks for watching Walrus Vision Toolbox Introduction to Charting video. In the next couple of minutes we would like to give to you a quick overview of the advanced charting capabilities of our software product. Digital image processing has common roots with signal processing. One-dimensional data analysis within the image pixels might cover up features which tend to hold useful information. Shows how the image has been created by analyzing the noise level of an image. Shows brightness variations and highlights image features with high precision. To support such measurements, Walrus Vision Toolbox has advanced charting features. Let's have a look at some of these options. Just drag an image from your operating system and drop it into the application's canvas. Select the Measure Distance tool from the toolbar, and draw a horizontal line across the gradient from left to right on the topmost part of the image. Select the Measure tab on the control bar. You may have noticed that all the measure tools are sharing some common controls shown at the top. With the Distance Measure tool being selected, click on the Draw Profile button. A new chart window will appear and shows the pixel values along the line. From the chart data, you may have noticed that the gradient from the dark area to the white is actually not that linear. This is coming from the fact that the drawing program being used to create this image is not designed to provide smooth and continuous gradients accurately. Now let's repeat the same on the mid-range of the image. On this part of the image, the pixel intensity values have been adjusted one by one, pixel by pixel. Now draw the same line from left to right on this image also. Click on the Show Profile button to draw the pixel values along the line in a new chart. As you can see, the gradient of this image does appear on linear fashion. Now let's measure the third section of the image. You can just drop any of the measures being created onto the same image to have a duplicate of it and move it to the right position. Click on the Show Profile icon again and compare the results. Here the two curves look pretty much the same. It would be great to compare the three profiles in one chart. With Walrus Vision Toolbox you can easily do it. Just change the color of each measure tools to red, green and yellow. Select them all and click on the Profile button. As a result, all three charts are appearing in one graph. Now the comparison is much easier while we can see the differences along the three gradients drawn in one chart. Now let's see another example when the measured line profile reveals useful information hidden before. To measure the noise characteristics of your imaging sensor, or just to compare the smoothness of your illumination system, you might want to compare background levels in different image regions. Just drop your image onto the application canvas. Using the Distance Measure tool, multiple measures can be placed on the same image and the profiles can be shown and compared on the same chart. By setting different colors to each measure, the datasets are easily distinguishable. In our example, the illumination on the left side makes the image evenly saturated, while on the right side of the image we have some background appearing. We have a noisy area 150 pixels wide of 30 gray levels darker than would required. In our last example we will show how the live update of the profile chart helps to set the measurement points exactly to the pixel location where interesting features are appearing. To check in our previous example if the centered holes are having the same illumination, just draw a new measure line. Click on the profile to make the chart visible and adjust the chart window size to a comfortable view. Drag the distance tool and the profile chart will be updated automatically. Find the position needed and highlight some data features. From the Details menu, click on the Details button to make data values and statistics shown on the graph. From the Markers menu, set the markers visible and bind them to data. Now we can see that the pixel values along the gear center are evenly saturated.